Morning, folks. Gonna give it a few more minutes for people to trickle in and to get these slides up. For those of you on the West Coast, go make some coffee.
Should have some audio as well.
Oh, good morning.
Good morning.
All right, I think we can get started. Morning, everyone. Good afternoon, everyone. Thanks for joining us here at MASQUE, the first inaugural session for this new working group. This is, Eric, can you go to the next slide, please? This should be a new experience for many of us using the Echo, either as a participant or a chair. So bear with us as we work through any sort of technical difficulties and trying to make this a successful and productive meeting. As is typical with most IETF meetings, when you enter the mic line or queue line to say something, please introduce yourself so that the note taker can get that down. We'll enter you into the queue so you can ask questions as the presentations go on, and you can leave the queue shortly thereafter. Please be concise at the mic. We only have like 20 minutes for each talk, and I'm hoping we can use that time for useful conversation and discussion. Next slide, please. And Sean, I see you. I'll get to you in a second. This is the note well. You may have seen it if you've been to any other sessions yesterday. If not, you're encouraged to read it. Please take it to mind. In particular, I'd like to point out the code of conduct. This is an online session, so be careful or just be mindful of what you say and how you say it. especially via text in either Jabber or in the chat here. Next slide, please. So here's some helpful links to help you follow along. You can, of course, join the Jabber room and follow along with the notes. Before we go any further, this is mea culpa on us, we do actually need a note taker and a Jabber scribe. So if someone would be willing to do that, that would be super helpful. And I'll pause here just for a moment so we can have our many volunteers step up.
I can do the Jabber scribe for you.
Thank you very much, Ted. We just need someone for notes then. All right, Ben Schwartz, thank you very much. Okay. Eric also helpfully pointed out that I forgot to mention this is being recorded, like most IETF meetings. So just take that into account, I guess. All right, so here's our agenda. We've gone through slide selection or scribe selection and the note well and everything. We have 4 presentations on the docket: CONNECT-UDP from David Skenazy, IP proxying requirements from Dallas McCall, QUIC proxying from Tommy Polly, and transfer considerations for IP and UD proxying from Magnus Westerlund. I'd like to pause here if anyone would like to take a moment to bash the agenda. Okay. All right. So then we'll proceed as planned. David, we will start with you. And you have 20 minutes, so use them as needed.
David, you haven't enabled audio. Now you seem to have done it.
All right, how about now? Is the audio coming through?
Yes, we can hear you.
Awesome, thank you. Apparently you need to join video and audio separately. Okay, so my name is David Skenazy, and I'm here to talk to you about CONNECT-UDP. Fair disclaimer before I start, it is 4:09 in California. I have poured myself a coffee but not finished drinking it yet, so any mistakes might be due to lack of caffeine on part of your presenter. All right, next slide, please. I figured I would add just a little bit of historical context here because it's not really written down, and I got some questions from folks, and I realized that it was kind of a mess of drafts, so I figured I would just walk through this a little bit for everyone. So MASQUE is actually an acronym for Multiplexed Application Substrate Over Quick Encryption, and is not named after what we should all be wearing to save lives during this pandemic. So it started actually a year and a half ago as just a single draft, which was a proposal to co-locate a VPN server with an HTTP server. And this was discussed at the IETF in March of 2019. And due to some really good feedback I got, the draft kind of split into multiple parts where all of the obfuscation part turned into its own HTTP header. So that's draft Skenazy HTTP bis transport auth. And then just the all the concepts of obfuscation and all like how to accomplish that got kind of split into its own draft because that was a part that not everyone at the IETF was interested in working on. And the part that folks were more keen on became draft Ashkenazi mask protocol. So that was discussed then this year in March. And kind of as we went through the chartering process for the working group, we kind of pivoted from mask being like a full-on protocol that had kind of a Swiss Army knife of VPN features to potentially building every like what used to be called a mask application as its own draft. So not a mask protocol, but individual drafts that work over HTTP. So that became CONNECT-UDP, which I'm about to present. And then more recent draft is the IP proxy requirements, which also came out of the chartering process. So we're going to be discussing that one later. Okay, next slide, please. So most of us are probably very familiar with HTTP Connect, but just to be really give you a very quick recap, it's been around for over 2 decades, published in IETF108-2017, supported in pretty much every version of HTTP, and it's pretty simple. The client tells the proxy to open a TCP connection to a host and port. The host can be an IP address or a host name, and then that stream forwards all of its data to the TCP stream between the proxy and server and back and forth. And that's it. Very simple. Next slide, please. But that only works for TCP. And wouldn't it be great if you could actually do this kind of exact same thing for UDP to carry a bunch of IETF protocols that don't use TCP? So we thought of doing something that was similar to Connect. The reason we didn't reuse Connect is that if you send the Connect method to an existing proxy today that is not updated to support like any new extension we want to add, it might just create a TCP connection where if you're trying to ferry around a UDP protocol would be completely non-useful. So we kind of went with the option of creating a new HTTP method. Next slide, please. So this new method is HTTP CONNECT-UDP, naming bike sheds obviously welcome. This is just a working title. And the idea is to do the same, but for UDP. So supported in all versions. That's because on the client to proxy leg, there are networks where UDP is blocked. So going over HTTP 2 or 1 helps avoid that. And there are some networks that use HTTP intermediaries and then only have HTTP 1.1 available between the intermediary and backend. So we would like this to work for those links. More details in a further slide. So how does it work? Very similar. The client tells the proxy to open a UDP connection to a host and port, and then it forwards that between them. So if you look in the slide, you have an example of what it looks like, HTTP 1.1. It's dirt simple. And then similar, you add a little bit of framing on the connect stream to have the limits of all your packets. And then you forward those there and then they're transformed into UDP packets in the proxy to server leg. And then, however, what makes this compelling these days is that for HTTP3, we can use QUIC DATAGRAM frames to avoid reliability. Next slide, please. So what does that mean? So right now this is built on another draft of mine, which is draft Ashkenazi QUIC H3 DATAGRAM. To give you a very quick summary of that draft, the idea is that QUIC has an extension called datagram frames, but the content of those datagrams is left to the application. And so when the application is HTTP3, that draft defines how to use the datagrams. And the way it does that is by appending a QUIC variable length integer at the start of each datagram to allow you to do demultiplexing. And then in order to be able to use those identifiers for anything useful, the idea is that both endpoints keep a flow ID allocation service that gives you like a unique identifier each time, even identifiers for the client, odd ones for the server. But that draft doesn't specify any sort of protocol to negotiate these. And so that's where CONNECT-UDP comes in and says, okay, so you send the CONNECT-UDP method and the authority, and then you add a new header, which is datagram flow ID, which tells you, okay, this is the datagram ID that we will use for this CONNECT-UDP. And the reason you want that is that on an HTTP3 connection, you could have multiple separate CONNECT-UDP to different servers within the same HTTP3 connection, and you use the datagram flow identifier to demultiplex them. Next slide, please. So conceptually, and apologies for this being not very clear in the draft. So I added this slide to sort of hopefully clarify what I meant. So conceptually, from the client's view of the world, the way I see this working is kind of similar to HTTP proxies. The client is configured to talk to a proxy. So let's say in this case, it's Proxy Corp. So it'll establish an HTTP connection to that, and then send a CONNECT-UDP, and then Proxy will then convert that to UDP packets to the end server. However, if we look at big server deployments of HTTP today, it's not always a single box that does all this. From the client's perspective, it feels like you're only talking to one machine because it's serving you your TLS certificate and terminating either your TLS connection or your QUIC connection. But in reality, you might be talking to an intermediary that is then based on the contents of the HTTP request you make, sending them to a different backend. So in this example, and you could also, by the way, have multiple intermediaries before the backend. And so in this example, the client actually has an HTTP3 connection to the intermediary, but that one in turn has, it can be an HTTP108 connection between the intermediary and the backend. And CONNECT-UDP will be routed from the client to the backend. So that's why we need HTTP108 for to support CONNECT-UDP, but it also makes it a little bit harder to ferry datagrams because they no longer work end-to-end from the client all the way to the backend, because that's a feature only available in HTTP3 and above. Next slide, please. I see Ecker in the queue. That do you want to let him in if it's a clarification question? Chairs, you have to, there you go.
It wasn't a clarification question, so happy to wait for the end.
It might be simpler if that's all right with you.
Sure.
Cool, thanks. Okay, next slide, please. So just, since we described the solution, I wanted to just...
I'm sorry, Chairs, can you throw me out of the queue, please?
So I just wanted to throw a quick slide about what I think is out of scope, because I really think that there are many, many cool things that you can do with CONNECT-UDP, and Magnus has a presentation later that goes into a great deal of detail on those. But I really hope that we can ship something very simple for CONNECT-UDP that is very closely min-mix just connect. But that we make extensible enough that all of these cool features can be added as extensions later. So for example, like notions about ICMP handling. If there's ICMP between the proxy and server, what do we do with it? If there's a NAT behind the proxy server, like IP fragmentation and other options. A new draft, which is UDP flags, that if you have the UDP length field, would allow to put some information at the end of there. We're not necessarily going to support that in the first one because it would add some framing overhead, but that could totally be done by an extension. Similar, like any kind of path MTU discovery, considerations with congestion control, so on and so forth. The v6 flow table, like ECN, and different services. All right, next slide, please. So this is kind of a question for the working group and for the community at large, because this is something we also want to discuss with the HTTP working group and the QUIC working group. But we have these two drafts. So one is the one I just presented, CONNECT-UDP, and one is a required dependency for it, which is H3 Datagram, which tells you how to use QUIC Datagrams with HTTP3. At first, the reason they're separate is that I assume that there might be some future protocols that would want to use flow IDs, but not tied to like a specific request. But I was told that maybe that's overkill, maybe that's not a useful feature. So do people have thoughts on that one? Do we specifically for merging these? I see Mike in the queue.
So now how do I?
We hear you.
Okay. All right. So that happened by itself. Great. Yes, I think there is value in keeping them separate, simply because if QUIC had datagrams when we were writing the H3 spec, there were several of the frames that we would probably have sent as datagrams instead of on the control stream. And that was a conversation in the time. We might revise H3 in the future to go in that direction. So it would be better to keep the flexibility, in my opinion.
Cool, thank you. All right, if there are any thoughts on this question, come on out. Otherwise, next slide, please. So another one is, from the multiple conversations I've had over the past few weeks, I'm noticing a pattern. So CONNECT-UDP, we just talked about. Tommy is going to discuss later today CONNECT-QUIC. And Dallas is going to present about IP proxying requirements, which could lead to a future method called CONNECT-IP, maybe. And yesterday we had a session of the Web Transfer Working Group. And all of these are starting to look very similar. We're trying to use an HTTP server to proxy something that doesn't look like a traditional HTTP request response. The way it's negotiated is via a specific HTTP request that looks conceptually similar to Connect. And then as part of that, you negotiate a datagram flow ID to allow multiplexing all these things together. And I'm wondering, is the best path forward to have all of these declare new HTTP methods? And that's a great exercise for greasing HTTP methods. Or maybe do we want to plumb this infrastructure of an HTTP method tied to a datagram once and then reuse it? So that one straw man for how that could look is, let's call it ConnectX, because I'm bad at names, and that way we can always have a bike shed. And it carries a ConnectX protocol header that is new for this and required. And if you don't have it, the server drops it, and then you would put, let's say for CONNECT-UDP, you would put UDP in there, and that protocol would tell you, okay, based on this, the server knows what to handle. And if the server doesn't know, it just responds telling you that it doesn't know what this protocol is. This looks a lot like how WebSockets are done for HTTP2, but it has the advantage of having a new method which sidesteps a lot of the complexities in extended connect that were due to the fact that it modified the base protocol. And the problem is then it required a setting, except the setting only works on one leg of the connection, so it doesn't get through intermediaries, which makes all that more complicated. Does anyone have thoughts on this? Like, is this reasonable? Should we go in this direction, or does that sound completely insane? So I'll pause here for thoughts and opinions and questions on this specific one. All right, Ted, I think we can hear you.
I just think that even though there are a bunch of these coming up right now, the friction around them is probably still going to be pretty high to get support from clients and servers and proxies for these. And so making this overly extensible, I don't think actually reflects kind of what the real friction level will be. So I think sticking with methods and going that way actually will make sense in the long term, even if it seems like at the moment there are 2 or 3 of these you want to handle. I don't think we're going to see 20. I don't think we're going to have a whole bunch of these suddenly emerging, so that we need the flexibility of CONNECT-X.
Okay, thanks. Thanks, Ted. That makes sense.
So, hi, Brian Trammell. Oh yeah, I guess I don't need to say my name because it shows up on the screen now.
Actually, please do say it, because MeetEcho is missing a feature to tell you which of the people in sending media is speaking. So it's really complicated for the note takers otherwise.
Cool.
Yeah.
Hi, I'm Brian Trammell. I'm going to say basically the same thing that Ted did for completely different reasons. I think we do need CONNECT-X. So I was just thinking about, I was trying to think this through, and it seems like there's like a very specific, you might be in a situation where you have a chain of intermediaries and you want to tell the intermediary what to use at each hop. And then in other cases, you can say that you don't care, right? Like, so that's the different semantics here. But I tend to agree with Ted that the friction here is going to be about implementation and configuration. So I would like to live in a world in which we could get CONNECT-X out, but I'm not sure we live in that world right now. And I don't want to block the progress on MASQUE on getting to a point where we think that's actually implementable, because we'll still end up having to have CONNECT-UDP and Connect, like the current Connect, and we'll probably end up having a Connect-QUIC that will go before a CONNECT-X would be widely implemented as well. So I agree with Ted, but for different reasons.
Okay, thank you.
All right, can you hear me?
Yes.
All right, this is Tommy Pauling. Yeah, so thanks for bringing this up. As you mentioned, I have some use cases that I'm currently just calling CONNECT-QUIC. I think some of these, like if we're doing them all in MASQUE together, there is room to connect them into a unified proposal. So like we don't necessarily need a separate CONNECT-UDP and a separate CONNECT-QUIC potentially. The CONNECT-UDP we can design may have more knobs than what your current draft has, but I do like Ted's overall point that once we have one shippable thing that works for a set of protocols, we can just push that out and not worry about it covering all future uses.
Cool. That makes sense. Thanks. And to one thing I'll add there is I totally agree. The CONNECT-UDP draft was written, it's a -00 as say, okay, what is the minimum? But after reading Magnus's draft, I've definitely been thinking that there are other the features that I marked as out of scope that should be available as extensions. So making sure that we have enough knobs to allow those, I think would be really important.
Martin.
I think I agree with the others, again, for different reasons. I suspect this design here is to take what you learn with doing the first one and reuse the design that you have, but not necessarily the spelling of that thing. So there's going to be intermediaries who will want to know about one of these methods for the purposes of, I don't know, blocking it or something. And so each one is going to have different behavior, particularly if you're actually terminating one of these things. You're going to have to understand QUIC in order to do the QUIC thing and UDP in order to do the UDP thing. And you're going to have to be able to do IP allocations and other things to do the IP side of things. So they're all going to require different functionality. So I don't see a problem with having multiple method / whatever the identifier is that we use to distinguish between these. So I would prefer to identify those things that end up being common and make them the same, but not necessarily make the mechanism generic. As in, I would say prefer composition rather than inheritance, and see how far that gets you.
No, yeah, and that's a good point. We can definitely have, let's say, for example, when we want to do CONNECT-QUIC, have it reference CONNECT-UDP and say, well, this is mostly the same, and here are the differences. Which, if you look at other HTTP methods, they have a lot in common. That's a very good point. Thanks.
Right.
Victor, you're up.
Can you hear me?
Yes.
All right, Victor Vasiliev. Two thoughts here. One is that it is unclear to me why those are like on some layer separate methods, because from the way you interact with them, it seems like most of them do the same thing, as it is you push datagrams back and forth. So it sounds like they're different types of payload or content types, but they're the same thing. And the second thought is that if we adopt HTTP route in WebTrans, you could layer all of this on top of WebTrans, and then you get all of this plus TCP fallback for free. Those are the two thoughts I had.
No, yeah, there's definitely a lot of similarity with web transport, and we might end up having like one layer on top of the other. We'll have to see the details there. I would prefer to not tie this to not tie the two at this point, because right now they're still pretty different, and we don't know which one will make more progress faster. But I do hope that at some point we'll figure out a way to unify these things, and maybe that doesn't mean one on top of the other. It just means that they look similar, as Martin was saying.
Okay, Magnus, we're going to cut the queue.
I think it's might too early to make a decision here about this, and I think what you say about extensibility, and I think we need to have a discussion about what MASQUE really is and what actually it means to forward datagrams before we decide on what features, etc. I think extensibility is an important aspect of it, which I'll come back in my talk, but let's discuss what we actually need to have from functionality wise, etc., and what we think is reasonable extensions before we make a decision here.
Oh, absolutely. And to clarify, I wasn't asking the working group to decide everything in the room today. This document, it hasn't even been adopted yet. It was just to kind of get a feel for the room and thoughts, and take, for example, like I'm hearing loud and clear that the ConnectX idea will look great on my shelf, and probably is not the way to go. So that was really what I was hoping for, which is great. And back.
Okay, hold on. Eric, can you join? There you go.
Don't double click. Or are the two chairs both pressing the button at the same time?
I'm not pressing anything.
Nope.
All right, I'm going to do it. Stand by.
Oh, no.
There you go.
All right.
Well.
All right. There. Wait. He's back in the queue.
I'm not sure what's happening.
This sounds like a glitch. Maybe you could put it in the Jabber.
Yeah, let's try that. Oh, nope. He's here. Eric.
Oh,
and
nope.
he's gone. Yeah, Eric, if you could ask your question in the Jabber or in the chat here, we can relay it for you.
All right.
Thank
So then I would say, so next slide. Yeah, so answer questions from previous slides. I think we'll definitely take those to the list. But then, I mean, all I'll let the chairs comment on where we want to go next, if this is ready for adoption or not yet. But then next slide, I think we can open this for general questions and thoughts and comments. And oh, perfect, Ecker's back.
Yeah, so I read this, as you may know. I think it's good enough for adoption. I mean, it seems to enact the thing that we agreed to do. The part that I have some concerns about is the proxy handling. I think the nature of the as you indicated, the nature of the proxies that people typically encounter at this point is that they're not aware of them, and the sort of apparent desire to push the capabilities of the proxy all the way back to the client via protocol mechanisms seems to me to be the wrong instinct. I think the right instinct is to require the proxy, each proxy in the front proxy in the system to be aware of the capabilities behind it and manage this negotiation appropriately, and to conceal the existence of their proxies from the client. We can certainly hash that out in working group discussion, but I think this probably is the wrong instinct.
Thanks. Yeah, no, and I definitely want to hash out the multiple proxies. I'm realizing that somehow we completely skipped that slide where I was talking about it. Chairs, could you bring me back to slide 8 just for 20 seconds, just because that was an important point I wanted to make, and I'm not sure how that got slipped. Apologies again, it is way too early here. So the previous slide was the one where we explained that, Proxy Corp can actually have intermediaries. And the question is, right now, I think the mechanism in the draft just doesn't work, but we could make it work by making the datagram flow ID a hop by hop header by putting in the connection header. And that was also a question I had for folks, because I think that would work. And like Ecker, since you're there, if you have any thoughts on that one or not. Was kind of especially a question for the folks that know HTTP intermediaries better than I do, if this is the right way to go for something like this, or if we need to keep iterating the design, which we can also do, like this. I'm just looking for pointers for which direction I should be digging in. You also have to join the audio, Brian, for it. Okay, and then the chairs have to let you into the audio queue as well. So
okay, ooh,
there we
yeah,
go.
I have audio, awesome. Okay, so I share a little bit Ecker's concern. I think there's a sort of an architectural moment, if we can, to take the fact that we're going to build a more explicit way of doing chaining connections through proxies to actually move away from the older instinct of proxy should be transparent and move toward an instinct of proxy should be transparent, in terms of not like you shouldn't see them, but you should have access to them at the endpoints for how you're going to chain these things. And I alluded to this a little bit in my thinking through why I thought ConnectX was a good idea, because you could actually say, okay, well, I want to build this chain of proxies. And if the available chain of proxies matches the chain of proxies you want to build, then it goes through. I don't see that as a impediment to adopting this draft as it is right now. But I think that we in this working group should actually have should take that on as a mission to make sure that anything that we build actually allows sort of this intentional creation of proxy chains and the intentional exposure of information about what that proxy chain is doing to the endpoints. That might have been a charter discussion moment that I missed by not paying attention to MASQUE back in March. If so, I apologize, but I think that, yeah, that's definitely something that can happen in a subsequent document.
Cool. No, and that's totally reasonable. At first, I hadn't thought about this at all, and folks told me that, like, for this to properly respect HTTP semantics, this use case had to be supported. But if we specifically decide as a working group that that is a non-goal, that actually simplifies things. So that's totally an option in my mind.
Yep.
Thanks.
Thank you.
Bring you up, Brian. All right, Ted. And the queue's cut here, just so everyone knows. Ted, you're up.
Relaying for Eric Nygren. Another reason a ConnectX might make sense would be for cross-protocol interactions, in particular for handling ICMP v6, responses to UDP messages such as for PMTUD/PTP, although the proxy may/will need to translate those regardless, so it may be that that's a special case, and just having a general mechanism for relaying those back across the various connect-star methods would also be fine.
That makes sense. Thanks.
Thank you. All right. Martin.
Oh, it works. So a connection isn't going to work for you in this case because we banned the use of that in H2 and H3. So that's going to make it a little bit difficult to do hop by hop messaging without using frames. But I suspect you're going to have to use frames or some sort of settings to negotiate the capabilities hop by hop anyway. Otherwise, you're going to end up in a situation where one or other entity that's involved in the chain is under the impression that they can send datagrams, but you don't have datagrams all the way down the pipe. I think Egger's point is probably right. You're going to need every single hop in the chain to indicate that it's willing to do this. Otherwise, you'll end up with problems like, oh, this is the ConnecT-UDP method. I'll just send that on as if we're a new method in HTTP, which is what proxies should be doing. And then it gets through to the other end, and that end actually understands it, and you have two ends with a middle that doesn't support the thing that they think they're talking about, and everything goes pear-shaped. I think what you have in your design deals with that reasonably well, but there's a couple of things that bother me in terms of making sure that the on-hop beat characteristics of this work properly need to be worked through.
Cool. Thanks. Yeah, that I knew there was a reason this wouldn't work, but I just couldn't find it. So perfect. Yeah, this is making me lean more towards what Brian and Echo were suggesting of like making that, explicitly maybe a non-goal, and that way we require like a specific setting on the H3 or H2 connection between the client and intermediary. That could be good. Ecker?
All right. Ecker, you're up.
So there seem to be actually, I think part of the problem is when we're using the word proxy, we're actually confusing a number of concepts, which maybe don't go together that well. The proxies I think you're talking about are although it's a little hard to tell with this diagram, but are what used to be called reverse proxies, right? In the sense that you have multiple hops between you and the back end. There's also what we eventually called forward proxies, which was the client does selection, and then there's basically, and those there's the sort of like the variety where they all appear to be integrated, and so you don't have the encryption, super encryption, and the ones where they're nested as in Tor. And so, so when we sort of talk about what behavior you want, really depends on which of the situations. In particular, it's like really hard to understand why you care about the internal topology of the server farm, but it's quite obvious why you care about the internal topology of your nested Tor tunnels. And so, we should probably historically, of course, reverse proxies were like a kind of quasi-invisible concept, whereas forward proxies were an extremely visible concept. So, which of these we're trying to deal with probably would be useful. I mean, we need some new terminology to avoid being as confused as we typically are.
Definitely agree, and yeah, this is definitely confusing, and I think we can do a lot better. Yeah, and focusing on the forward proxies makes a lot of sense to me. Cool.
Okay.
And
go ahead, David. Sorry.
I was just going to say, if you want to take us to the last slide, and then if the chairs have closing comments on what I should do with the draft now.
Yeah. So there seems to be a lot of general interest in the draft. Certainly, there's issues that need to be worked through. But as Eckers and others have pointed out, these are things we can work through during the working group. So at this time now, I'm going to be crazy and attempt to use the hum mechanism on Meet Echo. Sorry, Meet Echo, if you're listening. I'm going to ask two questions. One, if you are in favor of adopting this as a working group item, and no, you're not in favor of adopting this as a working group item. So the first one is yes. Are you in favor of adopting this as a working group item?
Hold on. Just sorry, before we jump in, I can't even find where I'm supposed to hum.
The top left
Is it in the
tab. next
Top
to the
left tab,
Jabber
yeah.
tag is going to have a
Virtual
little
hum tool. Okay, so in the top
Yeah.
left, there's a thing with an exclamation mark. Okay.
and you're
And I
going to
already
have
clicked
35
start,
seconds
and it
to
started
click an option.
instantaneously. So, yeah, this is interesting. Okay, so Forte results, great. Now I'm going to pause for a moment and ask the other question. And this is a hum for no if you're not in favor of adoption of this as a working group item. And here we go. The hum is up.
So I'm seeing some text in the Jabber saying that they wanted to hum for adopt, but didn't get there in time.
Okay, well, that's unfortunate, or that's irrelevant, I guess. The results are, people are mostly in favor of it. So thank you all for humming, and thank you, David, for the presentation. We will, of course, take this to the list to confirm, but I think we're all set for now.
Cool. So I'll await the adoption call on the list, and
Yes.
I'll hold off on making any changes until that's complete.
Perfect. Thank you. Wait, Martin has a question. Martin?
I have to click allow for the microphone every time, so bear with me. I see that some people hummed against this. If anyone's willing to speak about that, I'd really like to hear about that. On the list would be fine.
Yes, I really second that. All right, so that's all from me. Thanks everyone for listening. And how do I?
And Dallas, you are up. And you should be live.
Can you hear me?
Yes.
Okay, awesome. Hi, I'm Dallas McCall, and together with Alex Chernovsky and David Skenazy, we put together a draft of IP proxying requirements and use cases over MASQUE. Can you go to the next slide, please? Okay, so to begin, I'd like to describe the use cases that we considered while laying out our requirements. First off is that of a point-to-point connection. Here we're talking about two endpoints connected to one another with an IP tunnel, and they're just proxying IP packets between one another. We think that this would be a useful use case for building a more complex virtual overlay network. Next, we considered sort of a more traditional remote access VPN use case, which we're calling a point-to-network. Here, for instance, this could be your work laptop connecting to a corporate network. In this case, one of the points is actually acting as a gateway into some larger network. Next, we considered a network-to-network use case. We could also call it a site-to-site VPN. In this scenario, actually both endpoints are behaving as gateways into their respective networks. Can you move on to the next slide, please? Okay, so now that I've skimmed over the use cases that we considered, I'd like to kind of talk about the requirements that we're thinking about, kind of going from the base security requirements up. So as this is effectively a VPN, we believe that the transport that this runs over should be both mutually authenticated, confidential, and have integrity. So we believe something like QUIC or TLS should be able to satisfy this. Next, as this is MASQUE, the traffic that is generated as part of an IP session should be indistinguishable from regular encrypted HTTPS web traffic. In addition to this, the authentication that is performed for establishing an IP session, we believe should be separable from the authentication that is done when establishing the transport. I saw on the list that there is a question about this, so I'd like to explain that in a little bit more detail. What we're thinking is, for instance, if you use TLS to establish the underlying transport and the client authenticates the server, but perhaps the server doesn't authenticate the client, this would be a point where the server, the client could present some sort of token, such as an OAuth token or some vendor-specific authentication to authenticate itself to the server. Finally, I'd like to sort of state the obvious, but whatever identifiers that we use for actually authenticating one another and for providing the peers' identities should be cryptographically verifiable. Next slide, please. Okay, so moving to the session that will be running on top of the secure transport. And I see somebody in the queue. Is it a clarifying question? I guess.
When you say cryptographically verifiable, what do you mean in this context? Do you mean bound to the connection? Do you mean because an OAuth token is not necessarily conventionally cryptographically verifiable?
Cryptographically verifiable just we mean something that the other peer can in some way trust. I guess we can discuss that in more detail.
Yeah, I mean, because whether or not. Right. Okay. So this needs some clarification because that's not really a very clear statement in this case.
Okay. I think Alex has a comment.
Alex is in the queue, so I'll let him in.
Yeah.
Hi, can everyone hear me?
Yes, we can hear you.
Hi, I'm Alex Shanowski. I helped write part of this draft. I wanted to address a little bit of Ecker's question there. So when we say cryptographically verifiable, we don't necessarily mean that the data translated itself has some sort of inherent cryptographic property, but that it is verifiable by the server. So what you could imagine is doing something more like even a traditional HTTP web login where the cookie is somehow verified by the server. It could be like HMAC or something like that. The OAuth token is an example of one of the use cases that we're thinking of, which is explicitly supporting some sort of authentication mechanism other than the web PKI for clients. This is explicitly chosen as an extreme for something that we want to be able to support, not necessarily an example of something that everyone has to implement, because we just wanted to pick something that was sufficiently far away from what you would get by default with just regular TLS, mostly to ensure that we don't lock ourselves into, having client search or something like that.
Objective. I guess what I'm saying is I don't understand what the cryptographically is doing here. So we can take.
Yeah, I think we need to clarify the text, and that's a good point. Thank you.
Okay, thank you, Alex. All right, so moving on to the session requirements. To establish a session, we believe that it should be necessary for a client to send a request for an IP session along with some set of configuration options that I'll discuss a little bit more later. And once the IP session request along with these configuration options has been sent to the server should be allowed to either accept or deny the client's request at its own discretion. Presuming the server has chosen to accept the request, the primary purpose here is to proxy IP packets. So the protocol will go on to establish some form of data transport. We're envisioning using either QUIC DATAGRAMs, preferably, or perhaps stream frames to actually do the passing of these IP packets in their unmodified entirety. We believe that this should support both IPv4 and IPv6. Once we have a single IP session established over an HTTP connection, I believe it should be necessary for us to be able to multiplex these connections, or said another way, that we should be able to configure more than one IP session across the same HTTP connection. In addition to this, while we believe it's far preferable to use HTTP3 and preferably QUIC DATAGRAM frames, we also believe that it is a requirement that we should support at least HTTP2 in environments where either like UDP or QUIC are unavailable. Next slide, please. So now I'd like to move up to requirements of the session that we believe are very important, but should also be configurable. So to begin with, reliable transmission. So again, we're forwarding IP packets, so it is generally desirable to transmit these IP packets unreliably. However, there are a narrow set of circumstances where it actually makes more sense to transmit these reliably. So the protocol should provide some sort of mechanism to be able to forward these packets reliably. In that same train of thought, flow control should be configurable as well. So we should be able to entirely disable flow control if that is on an HTTP3 connection. Next, if we're using something like streams, we believe both the client and server should be able to create additional streams at their discretion. In some implementations, creating additional streams affords higher throughput, so either peer should be permitted to scale up as necessary. Next slide, please. This looks like I got cut off a little bit. So here I'd like to discuss the configuration requirements that we're considering for the actual IP session once it's been established. So first up is MTU negotiation. I saw on the list earlier that maybe negotiation is a bit generous of a word. All we're talking about is that they share the MTU and decide on a common one between either peer. Next up is IP assignment. This we considered specifically to address the point-to-network use case. Here, either peer, the client or the server, should be able to request to be assigned some IP address range. And in response, the peer that received the request should return an IP address range of its choosing. So to be a little bit more concrete here, this might be your work laptop connecting to your corporate network. The work laptop requests an IP address range of the gateway that is in your corporate network, and the gateway returns an IP address range that is routable from within that network. The next point here is of route negotiation. So we are using this to address the point-to-point and network-to-network use cases. And I also saw there's some confusion here on the list that I'd like to explain a little bit more detail. So here what we're thinking about is either the client or the server at any point in an IP session may request to advertise a set of routes to its peer. So this is saying I would like to advertise the routes X, Y, and Z. In response, the peer can reply with some subset of routes that it is willing to accept, or it can deny the request outright. So if the client said, I would like to announce routes X, Y, and Z, the server can say, okay, I will only accept routes X and Z. There's discussion of maybe we can use an existing protocol for doing this. I think that's entirely reasonable and worth discussing more. And finally, these configurations should be extensible. So as we were talking about in the authentication section previously, it seems entirely reasonable that once the actual transport's been established, we may want to exchange vendor-specific credentials while actually establishing the IP session. So we should have a reasonable extension point on these configurations to allow users to set back and forth additional useful configuration options. Next slide, please. Okay, so I'd finally like to discuss a few points that we've considered out of scope in our current thinking. First off is that of an addressing architecture. So both endpoints will have some address space that they're using. In the context of the IP session itself, we should not really care. These, from our perspective, are just opaque identifiers that are saying whatever is semantically relevant to either endpoint, but it's not important for the session itself. The next point is that of network address translation. You can think concretely in the case of like network-to-network connections. We may be bridging two networks who have private address spaces that conflict with one another. That's an entirely likely scenario, but we believe that address translation or other modification of the packets can be done within the endpoint perhaps, but on either side of the actual IP session itself. The IP session can be kind of scoped down to the dumb proxying of packets back and forth between each other, and you can do the network address translation before egressing into the actual network, for instance. And finally, along that same line of thought, is of how the IP packets actually transit from the physical network into this IP session and from the IP session back into the physical network. This proposal is again scoped down to specifically what happens from the moment that an IP packet is about to enter this IP session to the moment that it exits. Where it goes afterwards or how it got to the IP session is entirely out of scope of this discussion. And I believe that is the last slide that I have. So any questions or comments?
No, we only have 5 minutes or so, so please keep them brief if you can.
Okay.
Hi, this is Ben Schwartz. I'm just wondering, why is it that we end up having to invent things here? You know, my expectation would have been that IP tunneling is a solved problem, that we could just sort of adopt the language from any number of pre-existing standards for IP tunneling.
Yeah, so I think that's an excellent point. And I guess in this outline that we're discussing here, I'm not presupposing that we're going to reinvent this, mostly just laying out the sort of requirements that would be necessary for doing this over mask, if that makes sense.
Other questions? All right. Well, if not, thank you, Dallas. There's a lot of chatter going on in the chat right now, specifically around some of the definitions and requirements. I think this needs a little bit more time to bake, make clarity on some of the points and questions that were raised. But it's certainly a good step in the right direction. So we will, if you could perhaps follow up on this or make updates to the draft based on today's conversation, that would be useful. I see David's in the queue now, so I'll line him up. David.
Thanks, Chris. I just wanted to add, because I'm seeing a lot of really good feedback in the Jabber. Please, everyone, either send those as email to the list or as GitHub issues on the draft. The GitHub is in the repositories is in the draft. We want to take all of those into account post revision, which I think will be more polished that way. So yes, please send all your comments our way so we can take them into account. Thanks.
Thanks all. Thanks, Dallas.
Thank you.
If there's anything else, we move on to Tommy. I think you need to request to share audio. All right, there you go.
Okay, can you hear me?
Yes.
All right. Hello, everyone. So I want to bring up a proposal that I've been talking about with David and some others about how to further optimize CONNECT-UDP approaches and MASQUE in general for cases where we are proxying QUIC through QUIC. And as you see here on the slide, this is, you know, when we're talking about QUIC all the way down, and so it could be QUIC through QUIC through QUIC. Some people brought up earlier, you know, there are cases of multi-hop forward proxies, things like what Tor does. This is the kind of thing we're interested in here. I do not have a draft yet published for this. We are working on that, but sometimes our submission process is slow. But thank you for taking the time to listen to this anyway. Next slide, please. All right, so as you already heard about, the CONNECT-UDP protocol proposal allows tunneling of arbitrary UDP packets within H2 or H3. Particularly, it's optimized for H3 where we can do datagram frames. This is good, but when we are putting QUIC packets through this QUIC proxy, this is adding extra encapsulation and encryption for these proxied QUIC flows. And that extra encapsulation and encryption may be exactly what we want if we are thinking of this as a VPN, and we want to make sure that people looking at the outside part of the tunnel cannot see what's going on within at all, or at least see any of those packet signatures. But once we do have a fully end-to-end encrypted QUIC connection, there are cases in which we may not want to have to pay the price of processing overhead or MTU for having those extra layers of encapsulation and encryption, particularly if we have multiple hops. Tunneling this over and over again is more than what we need. And when we compare this to traditional TCP proxies, they, of course, because TCP is not, doesn't have that extra encryption layer, it doesn't have that same type of overhead. And so you can chain together a bunch of TCP proxies pretty efficiently. So we'd like to have something similar that we can do when we have multiple layers of QUIC. Next slide, please. All right, so here's basic diagram. We have our client talking to a MASQUE proxy. This is kind of acting as a forward proxy. And in the case in which we are tunneling through to a QUIC target, this kind of optimization would apply. Note that it doesn't do anything for cases in which the end target is something that is non-QUIC UDP or it's TCP. That makes no difference here. Next slide. But I think the case that is particularly interesting for optimizing specifically for QUIC within QUIC is when we have multiple proxy hops. Because in this case, if we are guaranteed that we are going through two MASQUE proxies that we know about, or two or more MASQUE proxies, these are cases in which that particular path, if we can optimize it, we can get a very nice end-to-end connection that has really nice privacy properties, getting something more like Tor. Next slide, please. So in the proposal, just calling it CONNECT-QUIC here, we can have the larger discussion about what different methods are. There would be two different ways of sending QUIC packets. One is what I'd be calling tunneled. And this is when the packets between the client and the target at the end are fully encapsulated within datagram frames between the client and the proxy. This is exactly what CONNECT-UDP does today. And in this proposal, I think it makes sense to do that for any QUIC long header packets that are end-to-end. Now, the other new mode here that we can get optimizations for is forwarding instead of tunneling. And so in this case, which is appropriate for short header packets, the end-to-end client target packets can be sent from the client to the proxy on its UDP socket without any extra encapsulation or tunneling, and then just forwarded from the proxy on to the end target. Next slide, please. So the setup here is based on what CONNECT-UDP defines, but it adds a couple new notions. So the part that it shares is the datagram flow ID. We need to still identify within the proxy connection which is the datagram ID that we use for tunneled packets. But in addition, we can define connection IDs that are owned by either the end server target or the client to use for mapping for this forwarding path. And the notion here is that I'm not just forwarding a given 5-tuple, I'm forwarding on the basis of connection IDs. And when I open a connect request, this connect request includes which connection ID I'm binding to a given datagram flow ID, and I want to open up a forwarding path for. And when that stream for the request to do that connect method closes, then I'm no longer interested in that connection ID being forwarded. Next slide, please. So as an example, let's say that I want to tell the proxy that I have a client quick connection CID that's given here, and I want to bind this to target.example.com 443 with datagram flow 1. And this will say that any packets coming from that target using this connection ID of the client can be forwarded directly to me. So in this case, we can just send the connect quick method. We indicate what is the server that I'm trying to bind to. And then along with the datagram flow ID, we add the connection ID that I want to bind. Next slide. So to look at kind of how this plays out in the packet exchange, so on these are the different entities. So on the far left, we have the client, then we have two proxies in the middle, and then we have a target on the end. So if I want to go through two proxies, every proxy that I talk to requires one RTT to do its initial setup. So I can do its quick handshake with the first proxy. And then through that, I do a connect quick, which is then sending the long header packets for the new quick connection for proxy, the second proxy in datagram frames. Looks like Martin is in the queue.
Martin, do you want to take the question now?
Sure.
Okay, Martin.
So I can wait. I just realized that there's no draft for this at the moment.
Yes,
And
I mentioned that at the beginning. It will be published soon. I very much apologize for that. We are waiting for our approval processes to churn correctly.
I understand. From what I've seen on the slides and from what you're talking about, I have serious reservations about whether this is going to achieve the goals that you've set for yourself. What are those goals?
The goals are to be able to, in the cases where we are doing multiple proxy hops for QUIC, not have to have the encapsulation encryption overhead for each of those hops.
Right.
So we don't need to put everything within more and more datagram frames and keep reducing the MTU and keep having the client have to do like 5 encryptions for every single packet that they send out.
Right. And I think that's a reasonable requirement, but I think the management of connection IDs that you've described here that I've seen isn't going to work for a proxy that has to manage multiple connections. It looks like what you said from the previous slide was that the client sets connection IDs that it expects the proxy to use.
So the client informs the proxy about connection ID mappings that it is aware of. So whenever it generates a new connection ID to receive packets, or when it is aware of a connection ID that it will be sending to, it essentially negotiates that with the proxy to say, this connection ID now exists, and it requires getting that response before it will start using that connection ID.
Okay, that's not clear from this. Okay, I'll let you carry on.
Yep. Okay.
So I guess I think I understand the performance objective, which you stated, but I don't think I understand the security objective. And you sort of said Tor-like, but Tor has some extremely specific properties, which are designed to prevent proxy collusion, and I don't think I understand how this prevents them. I mean, in order to prevent proxy collusion, you need to not have end-to-end identifiers, right? That's the whole point. So I guess I don't quite understand what the security properties you're attempting to achieve are here.
Right. So it is specifically, it's not going to have the same security properties as a full Tor type thing, especially because if you were able to observe packets on two sides of a proxy, you may see the same content going through. Now it is fully, it's just a quick short header packet that's going through, so you won't be able to, get anything more than if you were on the path already. So essentially, yeah, the goal here is we want to get the IP address obfuscation going through multiple hops, but we're not necessarily concerned about being able to reconstruct that path if you were able to observe all of the links.
Okay, I guess yeah, I think it'd be really helpful to talk about the security requirements, because the part of the reason why Tor has like multiple hops is to avoid various kinds of collusion, and it seems like this reopens a number of kinds of collusion. And so I think the threat, as usual, my question is, what was your threat model? So maybe we can start with that.
Yeah. So largely since we don't have the draft out there yet, for the purposes
I can wait.
Yeah, that's fine. What it's trying to point out is there is a possible mode of running CONNECT-UDP that has this optimization, and we need to determine when that's appropriate. But if that is appropriate, I think we should have the ability to do this type of thing rather than saying all QUIC proxies are going to have this extra tunneling overhead.
I think what I'm trying to determine is that have an interesting set of security properties, or is it yeah.
Cool. Alrighty. So getting back to the slides, can we advance the slide off of this one? Yeah. So some of the nice properties here are when we're actually doing the end-to-end connections, the overall kind of RTTs and overhead can be pretty low. So when we want to open up, like, let's say, an end-to-end TCP connection through 2 hops of masked proxies, the first hop just forwards a short header packet through the first proxy. It merely forwards that. That one then can include the actual connect requests, and then the overall connection can just be a 2 RTT thing. And next slide. And then this is even more efficient when we're doing end-to-end QUIC. If we were essentially okay with this data being potentially fingerprintable outside, we could go through multiple QUIC proxies without having to do any other extra encapsulation or encryption once we get into short headers for the end-to-end QUIC connection. Next slide. So the way that I've been talking about this here and have worked on writing things up is to say that it's a connect QUIC method. As David mentioned earlier, it may be possible to merge these types of things. So maybe not to have a fully extensible ConnectX, but at least have options that we can negotiate in CONNECT-UDP. Now, one of the interesting things here is this kind of capability of being able to forward packets really relies on having a proxy that is H3 capable, that is QUIC. This will not work if I am falling back to H2. So one of the requirements that this puts back on the Connect protocol is that there is some way to negotiate this capability with the server, or at least know that it's not supported and be able to fall back to a simple datagram encapsulation mode. Next slide. So in the discussion, some of the interesting areas to look at are how we can more efficiently have proxies be able to reuse upstream UDP connections between each other. There's a lot of trickiness around connection ID mapping. That can be pretty easy if you always have one UDP socket to the proxy and one UDP socket out of the proxy to the next hop. But if you have more complexity in the proxy about knowing how to map connection IDs, it would be possible to coalesce that into one socket on the outside. interactions with load balancers and other proxies can be weird here. So either you need tight coordination with load balancers or you are not going to be able to do this. I think there's also, as Ecker was mentioning, we need to look at the security properties, and beyond kind of the collusion protection, we also need to make sure that when you're forwarding that you're not vulnerable to attacks of just replaying, of forwarding replayed packets. And that's the end of my slides. So go to the queue.
Person in the queue, and we only have time for one quick question. So Ben, turn it over to you.
Hey, Ben Schwartz. I just wanted to say, you said that this is similar to CONNECT-UDP. And earlier you also said that this reproduces the low overhead forwarding of classic HTTP Connect for TCP.
Yeah.
So I think I don't agree with those two claims. For HTTP Connect TCP, I agree that it's low overhead in the way that you describe it, or in a sense zero overhead, but only in the case of insecure HTTP. For HTTPS, HTTP Connect still gives you multiple nested layers of TLS. And so you are doing, N encryptions, and you do have N HMAX or whatever
Sure.
of overhead.
Yeah, the thing I was comparing to was more just generic like TCP proxies, like a SOX proxy. Like if I want to do quick through like a SOX proxy, this is the equivalent of that.
I agree. I think that what you're describing here very much resembles what would happen if you ran QUIC over a SOX proxy or over a turn relay. And personally, I would lean toward basically emphasizing that. There's work going on right now in int area to specify a SOX 6, which is, I know you're well aware of that. I think that this might be better suited for that line of work where it's clear that we're not trying to maintain some sort of HTTP or HTTPS like security guarantee.
Sure. I think there is room for a mask proxy being able to do that type of thing, though. Because at least at this point, we don't have those, like a SOX v6 proxy is still going to be primarily running over TCP, and it itself doesn't have the same type of guarantees for protection of its own handshake. But we can talk about that more offline.
Sure. I guess my real point here is this is essentially an escape hatch that allows you to start inside an HTTPS session and then actually break out and have the client send, or actually a third party send arbitrary clear text that is multiplexed next to the ciphertext of the HTTPS stream.
Yes.
So that seems like a sufficiently odd design that I would consider trying to move that into a different protocol like SOX 6.
All right.
When the draft is approved, we can send it to the list and continue the discussion there. Great. All right. Let's move on then to Magnus. Right. You should be up and running.
So this is transport considerations for IP and UDP proxying, it probably should say, or tunneling, because, but there's a draft associated. This I managed to forget to put it on these in the slides, but there's a draft in the under the MASQUE working group, so you can read if you haven't read it already. I have my co-authors on there. So let's move on. Next. So I will try to keep this focused, and I think one of the important things here is that this CONNECT-UDP or datagram forwarding is not the same which the byte-stream concept of HTTP Connect has so far, and we need to really consider that. Show that, we'll look into some of the a bit of terminology, but also look at some of these cases where we need discussion about functionality here, etc., and what we should aim at, both for IP header fields and UDP header and also like ICMP. So next. So, I mean, this is a picture of where how I look on HTTP Connect from some sort of perspective. It's that it's an end-to-end byte stream semantics, in this case, utilized by, for example, TLS to reach from the client to its target. And you have back-to-back TCP sessions on top of etc. And that has the effect of that each of these TCP sessions, they really consume ECN bits, etc. They consume ICMP and all these things. All the network to endpoint signaling that could happen is consumed by that connection. So, and another relevant aspect, but I won't sticky, but it's like with TCP and other connection-oriented protocols, we usually can only have one single forwarding behavior or cross-level behavior on that flow. That's not the same true. That's not really true for UDP flows, because your subflows inside or even part of a subflow could potentially have different QS, and that has been tried with, for example, RTP, which is very flexible in that sense. So when you're trying to have an end-to-end datagram transport service, you actually need to consider what happens with the network to endpoint signals, such as ECN and ICMP. We also have the endpoint to network signals like these diff circle points. We also need to consider here a bit. So that's the kind of state here. And we're also coming from a point where with proxying, we are assuming that we're actually having the proxy generate the header, so that the IP UDP on the right side of the picture here would be created by the proxy rather than being tunneled. So, but this consideration would also apply to tunneling if you would try to do any type of compression of those headers. So let's move on. So terminology here, I'm using proxy for the mask server and the client, and between them we have path 1, and you talk to the proxy service address from the client perspective, talking to the proxy, and the proxy sends out packets towards the target from a proxy's external address to the target address. And address here, for IP UDP, we talk IP address and UDP port, or potentially domain names and UDP port. And we have UDP flows with 5 tuples and the reverse one, which goes back to the other direction. And for IP flows, we talk about the 3 tuples primarily. And you also have this, okay, we're going to aggregate multiple flows inside a single quick connection between the client and the proxy. And you will have some signaling flow for flow establishment and potentially asynchronous events, which will show that it's probably quite needed for supporting this functionality if you're going to have comparable to IP UDP end-to-end. So, next slide. So this is not going to go into details here, but it shows the which fields in the IPv4 header that needs discussions, which has some aspects of them that need to be considered. The yellow fields are things that are per packet and need to be set. But I mean, for example, the protocol field in IPv4, if you're using IP UDP proxying, then you know that this is fixed. It's going to say UDP here and nothing else. But if you have IP proxying, it's going to be whatever upper layer protocol that you use on top of that IP proxy. So you need per packet indication of that. Next. And the same here is IPv6 headers, very similar. So it's similar considerations. I would point out hop limit is actually for discussion in this. We have a special slide on this later. You're probably not going to get to it if you're going to have time for any discussion, but it's there and you can read the slide later. Next. Yeah, let's take this type of service, the ECN field, as one of these that we need to consider. If you're going to support ECN, non-support could be a possibility. I'll say, okay, specify that the proxy set's not DCT. But if you can have ECN support, which we worked hard to get into QUIC, for example, and it's slowly happening, etc., and ECN transparency in the network is good, and this would actually destroy that TCP in mask if we don't provide functionality. But we actually have two different paths. So for path 1, ECN is handled by that local QUIC connection that we're tunneling over. So any ECN marks or use of ECN here would be negotiated between the lower end tunnel used QUIC stack, and then we'll figure out, and it would react to the CE marks by reducing the congestion window. But to support ECN on path 2, we actually have to both have signaling for setting what ECN marking of ECT 01 should go out on from the mask server towards the target, and read in what's coming in from packets from the target back towards the client with the proxy, and propagate that information back to it so it can provide it up to the upper layer protocol, QUIC in this case. So this is kind of the basic functionality you would require for getting ECN to work. Skip 2 slides forward, I will skip the HTTPs. When it comes to fragmentation, I think the important aspect here is it's about controlling IP fragmentation, and independently if it's UDP flows or if it's IP flows, we're proxying. If you're going to run the upper layer protocol, is going to run any type of datagram packetization layer path MTU discovery, it requires control over the fragment. You also may have some application that's proxied over this, etc., that requires saying, no, I need IP fragmentation because that's the only fragmentation mechanism I have. It's maybe not works great, but in certain cases you can actually use it, even etc. So it's a trade-off here what we need, but I think we need something. You also have the other aspect of this, which is the MTU in this system in mask server. And so the mask tunnel between the client and proxy, if you're using stream, you could actually send up to 64K large IP packets across this Indian stream. If you're using datagrams, you're basically restricted to the path MTU minus the overhead that the QUIC tunnel adds. And you need to be able to indicate this toward the upper layer application, so it knows what's happening here about what the MTU that it can expect. And that's also in on the proxy external interface, you also have an MTU, which you need to consider. So, and basically the minimal between, etc. So that's need propagation. And then we have that, as already mentioned, the control over the don't fragment bit from the proxy towards the target. And it might be per packet, or it might be a default value that should be followed. So that shows a bit of what the mechanism is. Next slide. This is really a question about IP options extensions header. I think it's so far the existing extension header seems to be mostly things that the proxy would, if it were used, be added by this proxy on the path 2 by itself on the OS level. However, network tokens here is which is going to be presented more and side discussed this week, etc., is one of these cases where it might actually be the client that needs to provide data to the proxy that gets added to the and hop by hop option that's added in IPv6 datagram going out over path 2. And then you would need an extension. So at least capability extending for this for the future might be required. And it's something you should discuss. If there are people who think of other options or things there, please come to. And I think it's important we discuss this. But for the moment, I think we can live without the mechanism as long as we have a path for extending for this in the future. Next. Yeah, we can skip this. This is a very specific case, so go forward. The UDP header is fairly straightforward. It's mostly flow static when you have UDP, and the length field and the UDP options is really the only kind of special cases, because normally you can derive the UDP length from the IP length because you assume full packets. But with UDP options, you actually use the difference in these to signal that the UDP options is present. So you need to both be able to track if there's potential that this UDP options area is present, and how do you convey them. And this, in which options do you need to propagate from the proxy back to the client, or have the client provide data for to be added to the options area. So that's the future, at least the future extension capability that's needed. So next. ICMP is another thing which I think is quite important and relevant here. And the problems here, I think, with ICMP is that it provides network to endpoint signal that can improve the performance of the upper layer protocol, the end-to-end flow here. But with packet to big message or directly noticing that your destination is unreachable rather than timing out. But to be able to get that function, you're getting ICMP message back to the client, to the proxy, based on packets that go towards the target, and they are coming from the potentially, most likely from the routers on the path. With the source address you don't know, so that comes back to the proxy needs to look into this, match it with the outgoing packet flows, and then propagate the information from the ICMP message back to the client to enable this functionality. But I think it's quite relevant to strongly consider for inclusion in MASQUE to have that functionality, because it can greatly speed up things like PathMQ.
Oh, sorry. I think the audio is coming through. Just a heads up on time. We only have a few minutes left.
Yeah. So, there's one. Actually, skip 3 slides forward, because the ones that are is classifying the fields. But I really want to conclude here on the requirements. From my perspective, I see that we need per flow bidirectional signaling for asynchronous events like ICMP. And we need to be able to change default used values for setting things we send for a flow. We also need per packet information that needs to be certainly be flexible and extensible to be adding things for when packets have other than default values, or for example, if you get an extension header UDP options that need to be added later. So we need to be able to have that and add that to the per packet framing that's being sent. Also, the flow establishment clearly needs quite a lot of extensibility. I'm not worried about that, because so far I think we have seen quite a lot of things in this code that has these properties. So that concludes, so to say, the presentation part and comments, I think.
For a couple of quick questions.
Yeah.
Alex is in the queue. Alex, you're up.
Hi, Alex Ranowski here. I have a question about a bunch of these features. So in the CONNECT-UDP world, I'm sort of assuming that the direct datagram would be written directly into the MASQUE connection and wouldn't be going through an OS network stack. Is the expectation that user space will be doing things like implementing ECN and DSCP and all these other things entirely itself?
Which are you talking about, the MASQUE server now, or what's with? Sorry, I did.
Like, suppose that I wanted to write something that was using CONNECT-UDP, and I had some application that was previously directly using UDP. It wasn't necessarily aware of anything like ECN, because the OS would be doing that sort of work for it because it has the IP stack. So
No, but that's I mean, that's the thing, is that if you're looking at like QUIC as upper layer protocol over on top of MASQUE, that's doing the work with the ECN bits, etc. It's, I mean, that's
no, I'm talking about a regular UDP application which is now deciding to be proxied over MASQUE. It never was aware of any of these things before. Does it now have to implement them in user space because the OS kernel is no longer doing it for it?
No, but not more than you would do today to use them. But the application that wants to use DCN, like QUIC, etc., and maybe RTP, that has specifications for how to use DCN.
How is it getting those notifications? Because it's not getting like an OS like response code on readv or something like that.
But that's the thing, is that the MASQUE client interface needs to provide that in the API towards the upper layer protocol.
Okay, so you do expect applications to have to change to use these capabilities?
Well, it's I mean, if you're an application directly using a MASQUE client as your network transfer stack, then you of course need to have an API equivalent or better than what the SOCKS API provides you. And Socket API today can give you ECN bits. So
thank you.
Yeah. David?
Please keep it brief if you can.
Yes, David Skenazy, Google. So I just wanted to comment that, thank you for your presentation. I think some of these definitely sound like things that would be great additions to our ecosystem. That said, in your presentation, you've used the term like need and like on this slide requirements quite a bit. And I think what you're describing are needs and requirements for like an extension to CONNECT-UDP. Because leverage, like as Alex mentioned, leveraging requirements on a general mask stack sounds like something that we wouldn't necessarily be able to support. Like not every application needs this, and not every application can support this because of the kernel interfaces you might need, for example. Does that match what you had in mind?
So at the minute, I mean, I think there's certain things which clearly is difficult to implement, but I think the protocol needs to have potential support and extensible. And even if you're saying in certain cases, you're going to have to know what default values, etc., what you're putting in. So, and we need to consider what that means. And I think we need to discuss in certain cases, how important is this particular features? I have a certain view of which is more relevant. And I think, for example, ECN is one of these that's we start to see great deployment of, seeing that's great functionality for. We have QUIC, which is QUIC over QUIC, I think is one, or QUIC over MASQUE is going to be fairly common. And throwing away this functionality. But there are certain aspects here which is basically has to do with what needs, for example, around fragmentation, etc. That's really is basic datagram and being able to indicate it to get the right functionality working at all. So I think there's a base set which is needed for having a reasonable datagram service that you would expect from an IP UDP if you were doing it end to end. And then there's things that's would be extensible, that would require extensibility, but would be additional value for applications that fully supports them.
Nice, that makes sense. I think where I stand is that today ECN doesn't always get through the internet, and neither does ICMP, and so like MTU discovery and congestion control have to survive without them. So I think we can have CONNECT-UDP survive without them, but happy to take that to the list because I think
that's a good example. But I think, for example, setting the don't fragment bit is actually one of the critical things, because otherwise you don't know that your upper layered path MTU discovery works or not, because you might get hyperfragmentation on this path and you think you're not getting hyperfragmentation. So,
all right, Ian, we're over time, so if it's super quick.
Yes, it's super. Ian Sweat. I just wanted to say that the Connect QUIC option actually does mitigate a huge number of these issues. So for whatever that's worth, just an observation. That's it.
Yeah. And I mean, the alternative would be to tunnel the whole IP UDP protocols and let the client deal with the whole protocol stack. It would increase the overhead. So I think that's another way of actually leaving it to the client how much it implements of it. But that would increase the overhead. So thank you.
All right, thank you, Magnus, and thank you everyone for tuning in for the first Max session. Especially thank you to Ben and Ted for taking notes and being our scribe. We will follow up on the list regarding next steps for each of the documents, specifically the CONNECT-UDP and the IP proxying requirements. And unless there's anything else, we can adjourn here. Thank you all.
Thank you all.